Alright, we would like to find the distance between Dallas, Texas and Omaha, Nebraska, assuming the Earth is a sphere of radius 4,000 miles and that the cities are in the same longitude. Alright, so I'd like to have some kind of visual for this problem. There's my Earth. Here's the radius that it's asking us to assume. And so you need to imagine that you're looking at the side of the Earth. So here's one of our cities, and a little bit further up we're at another city. So I guess the one at the bottom would be Dallas, Texas, and it is at 32 degrees, 47 minutes, and 9 seconds. Whereas Omaha is at 41 degrees, 15 minutes, 50 seconds. Alright, so if we want to know how much distance there is between these cities, so that's not really going to be a straight line, there's going to be some curvature to that. So that would be the arc length of a circle, which we refer to as variable S. And in this section we are introduced to a formula that can solve for arc length for us. Pretty short little formula that says arc length is the radius which we have times theta, which I don't know yet, but soon as I figure out theta, can plug that in and answer their question. So theta is going to be the central angle, and it comes up very early in trigonometry. I think because this formula, even though it's pretty simple, it really only works if theta is in radians. So that's its connection to section 4.1. Alright, well, if I take these two angles, I can figure out the difference between those, which should tell me this, how wide that angle is having to open up. So I would really like to subtract those. Bigger angle, subtract the smaller angle. Oops. Alright, and to make this a little easier to see, I'm going to go ahead and change these into decimals as well. So 41 degrees, 15 minutes. 15 minutes would be 15/60ths of a degree. And I've got 50 seconds. And a second is a 3600th of a degree. I'm also going to change this to its decimal degree equivalent. So I've got 32 full degrees. I've got 47/60ths of a degree. And 9 3600ths of a degree. So, in the end, I really want to subtract these, and that will tell me the angle between those two cities, at least in radians. So, in my calculator, 41 plus 15/60ths plus 50 3600ths. This is about 41.264 degrees. And I'm rounding it on here to kind of sum it up, but I'm actually storing that in my calculator as X, so I can keep up with exact values. And now 32 plus 47/60 plus 9/3600. It's about 32.786 degrees. But I'm actually going to store that as Y in my calculator again, so I can keep an exact value. So X minus Y is 8.478 approximately. Now I'm actually going to store this in as well. I'd like to keep the exact value. This is a rounded amount, so just keep all my variables separate. I'm going to store that in for Z. Now a very common mistake is to say, okay, I did all this work. The angle between those two cities is about 8.478. Let me go and plug that in over here into the formula, multiply it by 4,000, and I get an answer. And you can do that, but you're not going to get the right answer. Because again, S equals R theta, that formula only is set up to work if theta is in terms of radians. So I need to convert this guy into its equivalent radian expression. So I'm going to take this, or approximately this, that I have stored in my calculator, and I'm going to do the conversion of pi radians divided by 180 degrees. So I can see that this needs to be in the denominator to make those units cancel. So I'm asking my calculator, what is Z times pi divided by 180? And that is approximately equal to 0.148, but now this is in radians. And while this is still in my calculator, I'm going to quickly multiply that by 4,000, and so S times R, or S equals R times theta, and theta had to be in radians, which is where we get 591.880 if I round to the nearest 3 decimal places. And since this is miles, this would be miles too. So the distance between the two cities, keeping an exact answer all the way to the very end. This is the only one I really rounded. I kept these exact by storing those in my calculator and using this exact in the calculator here. 591.80. Sorry, 591.88.